So let's see today's problem, rotation of array. So we have given a question, given a integer array nums, rotate the array to the right by k steps, where k is non-negative. Okay, so let's see. Uh, Taking example of a array, we have given nums array, which is 1, 2, 3, 4, 5, 6, 7. So the value of k is given as 3. So how can we rotate? Basically, we have to rotate the array k times. Means if k is equal to 1, we have to rotate one time. So what is the output if we rotate one time? 7, because 7 can't go here. So we can't put 7. So 7, 1, 2, 3, 4, 5 and 6. So this is the rotated array one time. So again we have to rotate it. K is equal to 2 means k. Now again we have to rotate k, so totally rotated 2 times. K is equal to 2. So again we have to rotate. The 6 can't go further, so we have to put in front of the array. So 6, 7, 1, 2, 3, 4, 5. Again we have to rotate an array because we have k is equal to 3. So total it comes out to be k is equal to 3 times. So again we have to rotate array. So 5 can't go outside the array, so we have to put inside. So 5, 6, 7, 1, 2, 3, 4. So this is our rotated array finally after rotating k times. So how we can get that this array? So the basic approach of that naive approach, we can say. So we make a temporary array to store the values which are going outside. Okay, to store the values which are going outside the array index. Now there are two parts in the array: 1, 2, 3, 4, 5, 6, 7. So part 1 is this, part 2 is this, and part 2 is this. So basically we have to move all the 4 digits ahead 3 step. So how can we do that? Basic operation swapping. So it will become 1, 2, 3, 4. Simple basic swapping operation, and store these three value in our temporary array. So our temporary array will be become 5, 6, 7. Okay. So now we put all these element in this array. So now our array becomes 5, 6, 7, 1, 2, 3 and 4. So now our array become this. So how can we? So it is a basic approach with having a time complexity of big of n and space complexity of big of n. So how can we reduce our space complexity from big of n to big of 1? So there is a simple beautiful approach for that. Suppose let's see, array is given as nums 1 2 3 4 5 6 7. So now what we can do, we have to reverse the array first from starting to n minus k times. Suppose the index is starting from 1. Suppose it's starting from index 1. So what will it look like? 1 2 3 4 5 6 7. Now we have to rotate the array first n minus k elements. So how will it look like? So reversing first element till the size of the array. Suppose size of the array will be n minus k. Here k is equal to 3. So it's look like this. After performing this operation, our array will look like 4 3 2 1. N minus k. N minus k is 7 minus 3 4. So it will come n minus 3, n is 7 minus k is 3 is equal to 4. Till 4 index we have to rotate it. Okay, after this rotation our array will look like this. We have rotated our first part. Now we have to rotate our second part. So for that we have to again perform reverse operation from where n minus k plus 1 till n operation. So n minus k plus 1, what will it come? N is 7 minus k is 3 plus 1. And what is our n? 7. So it will look like 7 minus 3 4 plus 1 5. 5 till 7. We have to rotate our array. So rotated array will be looks like nums equal to rotated array will be look like 4 from here to here. It goes from here to it comes here 4 3 2 1. Now fifth index is 5, seventh index is 7. So now we have to swap it 7 6 5. Simple. Now our both the parts of the array is now rotated. Simple. Now for the final part we have to rotate array one more time. Now we have to rotate our array, and now we have to rotate our array uh, fully. Basically we have to rotate it from first position till n. So what will it gonna look like? It comes out to be nums is equal to what will like 5 and 4 swapping 5 4. Now swapping 6 and 3, 6 comes here, 3 comes here. Now 2 and 7 and 1 at last. So now you can see the array which will get, now it is rotated k times. As you can see above operation 5 6 7 1 2 3 4, 5 6 7 1 2 3 4. So what is the time complexity? Time complexity of this is big of n, and space complexity is big of 1. So now we reduce our big of space complexity big of n to big of 1. So let's code it. Let me increase the size of this. So we are coding in C. So let's check. First we have to write the reverse function which will void type. We have to take integer array arr left part, left index and the right index. till we have to reverse it. So for reversing, while left is smaller than right, right till now. So for swapping in C, I am performing XOR operation. You can see my previous bitwise operator lecture to see how it will work. So we are taking array element left and perform bitwise XOR operation with array right variable. Simple. Now we will perform this 3 times. Here it come right, and we have to increment our left variable and decrement our right variable. So GST. Simple. And after coming to this, we have to write the function reverse reversing of the array. Reverse, basically we have to pass the array nums starting index. So here we can see, let me draw some. So how can we pass the starting and ending position? Suppose we have an array nums of 1 2 3 4 5 6 and 7. In array, the indexes start from 0 1 2 3 4 5 and 6. So starting index is our 6, starting index is our 0, and ending index is our 6. If we are given k is equal to 3, so which part we have to rotate first? So which part we have to divide in what parts? So for dividing parts, we basically takes and minus k minus 1. Why minus 1? In previous example, we are taking n minus k times. So minus 1 is because we are having index 0, starting with index 0, not from 1 2 3. Okay, so be careful because the index starts in array with 0, so we have to subtract it. Same with and position. For n, suppose size of the array is n, we have to pass it n minus 1. Okay, because the array is starting from 0th index. Okay, so let's see. First of all, we have to rotate element 0 till num size minus 1 minus k minus 1. Okay, then again reverse nums from num size minus k. Suppose our end is 6, k is 3, 6 minus 3 is 3, minus 1 2. So we will get 2. So from wait a minute. Yeah, here we don't have to keep it minus 1 because our end is already n minus 1. So here our end is 6 minus k is 3. So it comes out to be 3. So from third index we have to rotate first part. From third index we have to rotate first part of the array, and second half of the array is 5 6 7. So let's see. n minus k minus 1. because now here we are not uh, mm, let's make a variable. Suppose let's make a variable int and position, which is our nums minus size, num size minus 1. This is our and index. Okay, same with start index is equal to always start with 0. This is our sta starting index. Okay, starting index. So let's do some changes here. We have to pass it from the start till and minus k. Now from where will our next index start? From where will our next index start? Where is what? Yeah, so our next index start from, this is our and minus k. So our next index will be start from and minus k plus 1. Okay, till end. So let's see, it will gonna start with and minus k plus 1 till end, and third reverse will perform as from starting to the end, nums from start till end. Let's check. It's giving wrong answer. Why? Let's see. uh, what will be reversing two array? It's 4 1 1 2 3 7 5 6. Yep, it is reversing correctly. 4 1 3 and oh sorry, we have done a mistake. We are not performing right minus minus, so it will give an error. Yep, and there is one more condition. When you read the constraint of this test case, it says 10 raised to power 5. K is belong to 10 raised to power 5. So for this we have to handle a test case, so we cannot run into runtime error or TLE. For that, suppose we have to rotate array nums 1 2 3 4. We have to rotate array k is equal to 4. After rotating 4 times, we will again get the same array 1 2 3 4 after rotating. So why we perform extra operation to get the same array after rotating k times? So for that we put remainder of k, where k is equal to k modulo the size of the array, num size. So we can remove extra operation. Let's check whether it is running or not. Yep, it is running. Let's submit it. Yep, it is accepted. Faster than 66 and lesser than 74%. Thank you.